session we'll basically talk about the most common and most prevailing web application vulnerabilities and how the mitigation mechanisms that we can use to prevent those vulnerabilities. So as developers, when developing our web applications, to defend those web applications against these threats, we should see our web applications in an attacker's perspective. So when seeing, by seeing in attacker's perspective, we can see, we can identify how to bypass security mechanisms, how to slip through authentication, authorization, and how to attack our web application. So in that way, we know the enemy. We know how we can attack our web application, and after that, we should defend ourselves against those attacks, which is knowing ourselves. This quote is taken from a famous book called Art of War by Sun Tzu. OS Top 10 is a worldwide use guideline which is used for web application development as well as web application penetration testing, which lists 10 topmost security vulnerabilities which are found in web applications. So for the time being, I'll discuss only 5 of these, what they mean, and the OS is OS stands for the Open Web Application Security Project. It's an open source project. At the top of the list, we find injection attacks. I hope you all know what an injection attack is. In an injection attack, an attacker can include an arbitrary SQL command or any other shell command into your web server and execute it in your web server or your database server. For example, in SQL injection, attacker can execute an arbitrary SQL command that may be either to bypass an authentication mechanism, either extract information, simple information, or even to drop your entire database. And in command injection, an attacker will be able to execute a shell command in your server. In the demonstrations, I will show how these attacks will work. In broken authentication and session management, what it means is your authentication and session management system is insecure. An attacker can exploit it. Attacker can attack it to hijack another user session, or either to hijack an admin user session in order to manipulate that web application to its own design. The broken authentication and session management includes plain text password storage, session ID in URL. I will show you in the demonstration, and forever sessions. The sessions never expire, and session ID, reuse of the same session ID over authenticated and unauthenticated sessions. And the third one is cross-site scripting. I think most of you know what cross-site scripting is. But the critical thing is, most people think cross-site scripting is not so critical, since it is simple to exploit. This cross-site scripting is extremely critical because attacker can execute any script on the web page. Scripting means executing actions on the web page, clicking buttons, and even posting things. This might happen if you reflect the user provided input directly into your web page, either without encoding or filtering, or without validating the input. And security misconfiguration. Security misconfiguration can happen both in the server side and the web application side. In server side, we might find unnecessary ports open. There might be other services running on our web server. The ports are open. You don't know that the ports are open. Attacker can the service might be even unauthenticated. Attackers can connect to those ports and execute actions on your web server that you don't know. And there might be outdated software, say for an example, outdated Apache software, and reveals stack traces in server error pages, and information leaked to response headers. In this example, the server header. Sometimes when we request a web server, in the server's response, there's a header called server header. If you enable that server header, it's by default enabled in most cases. If you didn't disable the header, the server header will reflect the server's type and the version. By looking if that's outdated, that the server is outdated, attacker can use that value in the server header to find out the possible vulnerabilities and the vulnerabilities that are found by other people, and to execute the exploit those vulnerabilities. Cross-site request, forgery and clickjacking. As its name implies, cross-site request forgeries happens between two sites. Sometimes you might do something on a web page, but what happens is not what you intended to happen. When you for an example, in clickjacking, you click on an element on the web page, but there's a hidden iframe moving with your cursor. You click on the when you click on the web page, you actually does not click on the actual web page, but in the hidden iframe that might do something else that you never thought. And this cross-site request in cross-site request forgery, the server will not validate whether the request coming from the actual user or from the attack from the attacker. So in this demonstration, what the server does is it simply appends the value that we place inside this user input and append it into the at the end of the SQL query. And when we include this in the text box, the SQL query is something like select all from user. User ID is equal to 1 or 1 equals 1, and the other part of the query, whatever the part that might be, the other part will be terminated because this is a SQL comment. And what this returns is true. That means all the values of the database table will be returned to the front end. So that's an example for front end SQL XSS prevention mechanism by default, and the script does not get executed on Google Chrome, but in Firefox that script gets executed. Particular URL comes from an actual web page of its own or from some other web page. But now you are going to this unsubscribe page and click on unsubscribe. We get invalid CSRF token because attacker cannot regenerate this CSRF token, which a new token is created for every request. So server does not validate the request, and this operation does not happen. And I'll show you one more thing. The server logs might be available externally. You might not know. For an example, in ASP.NET applications, there's a URL page. There's a page called Elma, which can be accessed through a URL, which shows the log of error logs, exceptions for your web server. We can find attacks for most of the web servers and most of the applications. So if you does not leak those information to the attacker's hands, these kind of the attacks for your web application will not happen. So the rest of the presentation will be done by
Deepal told you and explained many security risks that associated with web applications. I am going to tell you how to prevent these web attacks and protect our web applications. When protecting web applications, we have two approaches. One is we can implement the security features in our own application, or we can implement them in we can use a server, something like Nginx, to protect our web applications, which has already implemented those security features. Implementing security features into our own application is a tedious task. As for example, if we have several web applications, protecting our web application from all those attacks Deepal explained is difficult. Therefore, we can use something like we choose Nginx to protect our web application. So the big question is, why Nginx? All you know, when you say web server, what comes to your mind is Apache. So first thing, why Nginx? First thing is the smart architecture. Nginx and Apache, the main difference between these two web servers is that Nginx uses a synchronous approach to handle requests, and Apache uses a threaded process oriented approach for the same for handling requests. What happens is, when a web server gets a lot of requests, Apache servers generate more threads, and these threads compete with each other for resource and RAM. So as the number of requests is increased, it will eventually request will get the response that service is not available. Nginx was initially built to overcome this problem, the C10K problem, which is a web server which can handle 10,000 concurrent requests. Next thing is, Nginx is open source and it's working on Windows and Linux, which is an optimal choice since our servers are using Linux. And the next thing is smaller size and better performance. We have actually deployed Nginx in our production servers, and even while doing testing, penetration testing and load testing, resource used by Nginx is very low. It doesn't use RAM or CPU much. Next thing is easy configuration and good documentation. Setting up Nginx is also behind the other thing is the stability. Over 10% of the top 1 million sites use Nginx. It has a pretty impressive clients like Netflix, Box and Hulu. Practical implementation with Nginx. Main thing is, as I mentioned before, no need of application level security headers. Or we don't need to secure our web applications in the application level. We can do it with the Nginx support. The other thing is, Nginx can be also used as a proxy service. For example, let's say in our gateway we have two versions of gateway, and one post machine calling to gateway version 1 and the other post machine calling to gateway version 2. We can set the both machines. We can set the same URL, let's say payment-leapset.com, and add the header for the request like API version 1 and API version 2. Nginx will proxy those results to the relevant gateway server according to the header. Next thing is use case. For gateway to go production with native credentials, we need to get a PCI DSS compliance, which means payment card industry data security standard. We need a certified report that our payments gateway servers are certified EPS in our product, which is admin console. But then as you can see, as you can remember, Deepal mentioned several security attacks. It feels like that to prevent our web application from these attacks, we will have to do a lot of work. But it's not that hard. We can do it very easily in Nginx. Servers from almost all the attacks Deepal mentioned. Now Smith to disable content type sniffing. This means that when a certain web page is loaded from a web browser, if the content type is not set, it will not load, and it will not load the content. This gets secure our web application from MIME type attacks. You can security and next thing is explain options. Next thing is cross-site protection filter. If you can remember what when Deepal did the presentation, the cross-site scripting attack works on the Mozilla browser, but didn't work on the Firefox browser. It's because most of Chrome it didn't work, Firefox it worked. It's because most of the recent web browsers usually enable cross-site scripting, enable cross-site script preventing, but some browsers don't. But you can simply, if a even if a user disable cross-site script preventing tool from browser, if we set the next thing is content security policy, attackers can actually inject script into our website. But what this header does it instead of blindly trusting everything that a web server delivers, this create a whitelist of sources, so that the website will only load these sources from this whitelist location. For example, let's say even an attacker can find a hole which to inject a script, the script will not run because the script is not on the whitelist. Protocols, there are some versions of SSL protocol versions which are not secure. We can enable only the secure SSL protocols in our web applications. This is actually checked with PCI compliance report whether these unsecured SSL versions are disabled. Next thing is SSL prefer server cipher score. This enables from our side from these attacks. It means that some ciphers used for encryption in web services are not very secure. For example, if I go to the airport and there is a Wi-Fi hotspot and I log in, I think it's from the airport, but if actually that hotspot is created by an attacker, then I try to log into my bank account, and my details can be attacker can get my details. But if we have enabled only secure ciphers, transport security, it means that we have enabled in our gateway servers as well, that we make sure that each login or each request must be a HTTPS request. Otherwise, attackers can get the request from get the request information. If it's not HTTPS, we can. Any questions?